Welcome to today's lesson on the extraction of metals, with a focus on iron and aluminium. This is an essential topic in chemistry, and examiners often test it with both theory and application questions. Most metals are found in the Earth's crust as compounds, not as pure elements. To obtain the metal, we must extract it from its ore. The method of extraction depends on the metal's reactivity. The reactivity series is the guide for choosing the extraction method. Metals above carbon in the series, such as aluminium, are extracted by electrolysis. Metals below carbon, such as iron, can be extracted using reduction with carbon. Exam tip: always link extraction to the position in the reactivity series. The ore of iron is hematite, which contains iron 3 oxide. The ore of aluminium is bauxite, which contains aluminium oxide mixed with impurities. Exam tip: learn the names of the ores. This is a frequent short answer question. Iron is extracted using a blast furnace, a tall structure where different chemical reactions happen as the materials move downwards. The raw materials added are hematite, which provides the iron 3 oxide; coke, which is a form of carbon and acts as the reducing agent; limestone, which removes impurities; and a blast of hot air, which provides oxygen for combustion. Note: in answering exam questions, always mention the role of each raw material in your answer. The process begins near the bottom of the furnace, where coke reacts with oxygen from the hot air. This produces carbon dioxide and releases heat, keeping the furnace at around 1500 degrees Celsius. The high temperature is essential for the reactions that follow. As the carbon dioxide rises, it reacts with more hot coke higher up in the furnace. This forms carbon monoxide, a gas that acts as the main reducing agent. Without this step, the reduction of iron ore could not take place effectively. Now comes the key step. Carbon monoxide reacts with iron 3 oxide from the hematite. The iron 3 oxide is reduced to molten iron, while the carbon monoxide is oxidized to carbon dioxide. The molten iron sinks to the bottom of the furnace, where it is collected. Exam tip: always give the balanced equation for this reaction in exams. It shows reduction and oxidation clearly. The limestone added has a vital role. First, it decomposes due to the heat, forming calcium oxide and carbon dioxide. The calcium oxide then reacts with silicon dioxide, which is an impurity in the ore, to form calcium silicate, also known as slag. The slag floats on top of the molten iron and can be removed. It is later used in road construction. Aluminium is too reactive to be reduced by carbon. Instead, it is extracted from bauxite using electrolysis. The aluminium oxide is dissolved in molten cryolite. Cryolite is a compound that lowers the melting point from over 2000 degrees Celsius to around 1000 degrees Celsius, making the process cheaper. Exam tip: always explain why cryolite is used. This is a common 1-mark question. In the electrolytic cell, aluminium oxide is broken down into aluminium ions and oxide ions. At the cathode, which is the negative electrode, aluminium 3+ ions gain electrons and form molten aluminium. At the anode, which is the positive electrode, oxide ions lose electrons and form oxygen gas. The half equations summarize the reactions clearly. At the cathode, each aluminium 3+ ion gains 3 electrons to form aluminium atoms. At the anode, each pair of oxide ions loses 4 electrons to form oxygen molecules. One problem with aluminium extraction is that the oxygen produced at the anode reacts with the carbon electrode. This produces carbon dioxide, which gradually burns away the anode. As a result, The carbon anodes must be replaced frequently, which increases the cost of the process. The extraction of iron and aluminium shows a clear contrast. Iron can be extracted relatively cheaply using coke as a reducing agent in a blast furnace. Aluminium requires electrolysis, which needs a huge amount of electricity and frequent replacement of anodes. Pause. 1. This is why aluminium is more expensive than iron, even though aluminium is more abundant in the Earth's crust. Iron is strong and can be made into steel alloys, which are used for buildings, bridges, ships, and tools. Aluminium is lightweight, resistant to corrosion, and a good conductor of electricity. This makes it suitable for aircraft, drink cans, window frames, and overhead power cables. Exam tip: be ready to give 1 or 2 uses of each metal with reasons linked to their properties. Let's take a look at an exam-style example. You are given equations for some of the reactions in the blast furnace. You are asked to name the substance which provides the carbon for this reaction. State the purpose of the combustion of carbon in the blast furnace. State the name of the iron ore. And lastly, write the symbol equation to show the reaction that occurs when iron, 3, oxide is converted to iron in the blast furnace. You can pause the video and give it a try. Here are the answers to the question. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.